All right, well, welcome everyone. I am JJ. Let's tackle an example problem. So in this one, we have box W is hung and supported by cable AB here off of our ring, cable AC, and then we have a spring that goes from A around a pulley at D, around a pulley at E, and down to our box. When the box was hung, our spring up here stretched 8 millimeters. Let's determine what's our mass of the box, what's our tension in AB, and what's our tension in AC. So 3 things for us to come and find. First thing though, we need to figure out, I have 3 realistically cables in here, just treat that spring like a cable. But I could actually find my force in my spring right away. I know it stretched 8 millimeters, I have a K value. I know that F equals KS is my spring equation. If K is 312.5 and my stretch is 8 millimeters, I can work with that. This is getting us that our force in spring ADEW, FADEW, is going to get us KS, 312.5, times how far it stretched, 8 millimeters, times 8. Checking our units, we are in newtons per millimeter, and our stretch was 8 millimeters. The millimeters will cancel, and we'll be left with newtons. This force comes out to be 2,500 newtons. We were asked for a mass of our box, though, for an answer. So this isn't actually one of our answers. We need to convert from force into mass. And a mass, that mass of our box, ADEW, should be our force divided by gravity. 2,500 over 9.81. Force is mass times gravity, so mass is force divided by gravity. And we can get our first answer here. That mass of our box, MADEW, is going to be equal to 254.84 newtons divided by kilogram meters per second squared is going to leave us with kilograms. Or our mass is about 255 kilograms, which would be our very first answer. From here, we got to move in and tackle particle equilibrium. So I have everything connects in at point A. I'm going to draw my free body diagram here at A. So I circle A, only the things that cut that circle pass through should show up in here. Really, that spring going straight over to the right is all I include in here. That piece that goes around the pulley, I could ignore that. I could ignore it coming down here and down. None of those are going to show up in here. I just want one force straight to the right because that's what it's doing as it leaves the particle we're working with here. Everything else is just in there to see, do we understand if we get the weight here, the mass here, it's the same everywhere in here. So let's draw our free body diagram. Our free body diagram, we'll put in a point A, and then I cut through 3 things. Cable AB should go up and to the left, so get that in there. I name my force. Let's call that TAD, or TAB for the tension in AB. TAB. And I know it's acting at a 60-degree angle from horizontal, so we'll label that 60 degrees. I also have cable AC that I cut through. It's going down and to the left as it leaves my free body diagram circle. So I should show it pointing down and to the left. Down and to the left. Let's call that TAC. The tension in cable AC. And I'm given triangle pieces for this. 5, 12, 13. So let's go ahead and label those in here as well. 5 vertical. 12 was the hypotenuse. 12 was our adjacent, 13 is the hypotenuse. And then the very last thing is I have my spring leaving point A here. And I already found that spring. It is 2,500 newtons. We pull that force piece in, not the mass piece into this. 2,500. Again, that is R equals F A D E to the weight. I have 2 unknowns in here. I can apply equilibrium and find those out. I have 2 unknowns in the y and 2 unknowns in the x. It really doesn't matter which equation I set up first in here. Let's start by summing forces in the y. If I sum my forces in the y direction. So we're setting up what equation am I working with? We're summing forces in the y. Then we'll get everything that has a y component in here, set it equal to 0. But I have TAB has a y component. So TAB times the sine of 60 gets our y component here. TAC points downwards, so we subtract it out. Minus its y component would be our y leg of the triangle, 5, divided by the hypotenuse of the triangle, 13, times our force, TAC equals 0. Which when I solve that, I can't get it solved out, but I can relate one of those variables to the other. I could either get like a TAB equal statement or a TAC equal statement. I'll still have two unknowns in there. But let's get this to TAB. This would reduce to TAB. I'm just moving that 5/13 TAC to the other side and dividing by sine 60. Is going to get us equal to 0.444 TAC. Notice in here as I go through that, I got rid of my fraction, my trig identity right away. Don't try to carry those through your work. It makes everything unnecessarily difficult. You're going to make algebra mistakes if you try to carry fractions and trig identities. Get rid of them. Simplify your math down. Do this in the easiest way possible. Don't carry trig functions through all of your math. It's never helpful for us. But that is one equation, one unknown so far. I can also sum forces in the x. So let's go ahead and tackle that one. So if I sum forces in the x direction, sum my forces in the x, I'm going to have, well, the 2,500 is entirely in the x, so 2,500. TAB points to the left, so it's negative, minus TAB cosine 60. And TAC points to the left, so it's also negative, minus our x leg of the triangle, 12, divided by the hypotenuse, 13, TAC equals 0. Which I could try to resolve this and get a TAB equals or a TAC equals, but in all honesty, because I have this constant in here, this equation is going to be messier. If I try to get a TAB equals and sub it in back up here, it's really messy to do that. I'm going to be way easier if I sub equation 1 into this. This is my second equation. So we can just substitute in so we can rearrange as well. Let's not worry about rearranging. We'd have 2,500 equal, or minus, not equals, minus TAB, but I know TAB is 0.444 TAC, so minus 0.444 TAC times my cosine of 60. Cosine 60 is 1/2 times 0.5. Again, get rid of that trig function right away. Minus 12/13, which let's convert that also to a decimal. Don't carry the fraction in there. 12/13 is 0.9231. So 12/13 TAC gets us equal to 0. Which in that equation, TAC is now my only unknown. I can solve and I'll get that TAC is equal to 2183.15 newtons. Which should be our second answer for our problem. We already got the mass. We now have TAC figured out. With TAC known, I can substitute into either equation 2 or equation 1. Again, be smart with what we choose here, though. If I substitute in here, my equation is still kind of messy. If I substitute into equation 1, I pretty much immediately get TAB. TAB into what? Equation 1. This is going to be 0.444 times TAC times, we just found it was 2183.15. Or TAB is equal to 969.57 newtons, which is our second answer for our problem. Again, really, we're just applying some of the forces in the x, some of the forces in the y, finding our unknowns. We're also pulling in, though, we know F equals Ks. I can find the force in the spring using that. But hopefully this is a useful video for us. If If it was, hit those like and subscribe buttons. Stick around, watch more videos. Let's get you in there with JJ.